Let's see the example problem on determination of EOQ and optimal total cost. A stockist has to supply 400 units of a product every Monday to his customers. He gets the product at 50 rupees per unit from the manufacturer. The cost of ordering and transportation from the manufacturer is 75 rupees per order. The cost of carrying inventory is 7.5% per year of the cost of the product. So find first one, the economic lot size. Second one, the total optimal cost including the capital cost. So let's see the solution. First we have to write down the given data. So here it is given a stockist has to supply 400 units of a product every Monday to his customer, which means it is given the weekly demand, which is the 400 units. So there are the 52 weeks per year. Then annual demand will become the 400 into 52. So annual demand capital D equal to the 20,800 units per year. And next it is given the he gets the product at 50 rupees per unit from the manufacturer. So it is given the unit cost capital C equal to the 50 rupees. And next it is given the cost of ordering and transportation from the manufacturer is 75 rupees per order. So it is given the ordering cost C0 equal to the 75 rupees per order. And next it is given the cost of carrying inventory is 7.5% per year of the cost of the product. So inventory carrying cost CH equal to the 7.5% of the unit cost per year, which is equal to the 7.5% into 50 rupees, which is equal to 0.075 into 50. So inventory carrying cost CH equal to the 3.75 rupees. Let's see the solution. So here you have to determine the economic lot size and the total optimal cost. So this model belongs to the model 1A EOQ model with a constant rate of demand, because here it is not mentioned any shortage cost as well as the production rate. So this is the model 1A. So in the model 1A, we know the economic order quantity EOQ equal to the root of 2D C0 by CH. So here D annual demand is given and C0 also given, CH also given. Substitute all these values. Then EOQ equal to the root of 8,32,000, which is equal to the EOQ equal to the 912 units. So we determine the economic lot size, that is the economic order quantity 912 units. In general, we are representing the Q star. Next we determine the total optimal cost. So that is the TC star, which is equal to the fixed purchase cost plus ordering cost plus carrying cost. So purchasing cost equal to the D into C. So annual demand into unit cost. And ordering cost is the number of orders into ordering cost per order, which is the D by Q star into C0. And carrying cost is the average inventory into carrying cost. So average inventory is nothing but 1 by 2 into Q star, and carrying cost is the CH. So TC star equal to the DC plus D divided by Q star into C0 plus 1 by 2 into Q star into CH. So we know all the values. Then TC star equal to the 20,800 into 50 plus 20,800 divided by 912 into 775 plus 1 by 2 into 912 into 3.75. Then so TC star equal to the 10,40,000 plus 1,710.5 plus 1,710. Then total optimal cost TC star equal to the 10,43,420.5. So this is the solution, and thank you.